Hello and welcome to this video. In this video we're going to learn how to draw quadratic graphs. So we've already looked at how to draw linear graphs if we have an equation in the form of y equals mx plus c, but now we want to see what if we had something that was in the form of something like ax squared plus bx plus c, so a quadratic equation instead. So let's take an example. Let's just take any quadratic. Let's say we have x squared plus 3x minus 10, for example. Okay. What we did for a linear graph was we always had a table. So if you remember, we had a table here that looked at all the values of x corresponding to all of its values of y. So we said x, and we went from -1, 0, 1, 2, and 3. And this column at the bottom, or this row at the bottom, was the y values, because this is going to be equal to y, okay? Because it has to be an equation for it to be able to be plotted on some axes. And what we did was we just said in the linear case that let's just take this -1 and substitute it into our equation. And that's exactly what we're going to do for quadratics, exactly the same. We're just going to say y must be equal to -1 squared plus 3 times -1 minus 10. Now -1 squared, if I have a -1 times -1, two negatives give me a positive, so this is just +1, minus 3, and then minus 10. So this is 1 minus 13, which is going to give me minus 12 here. And if I have 0, if I say y is equal to 0 squared plus 3 times 0 minus 10, that's going to give me minus 10. Then if I have y equals x equals 1, so y is going to be equal to 1 squared plus 3 times 1 minus 10. This gives me 4, and 4 minus 10 gives me minus 6. And then if I want x is equal to 2, then y is equal to 2 squared plus 3 times 2 minus 10, and this becomes 4 plus 6 minus 10, and this becomes 0. Okay, so 4 plus 6 is going to give me a positive 10, minus the 10 gives me 0. And then finally, if x is equal to 3, then this is 3 squared plus 3 times 3 minus 10. So this is 9 plus 9, which is 18, minus the 10 gives me the 8. Now, this range that we've got here is not going to be big enough for this equation, because as you can probably tell, in this case, we're moving up each time we're essentially just going up. If we have a quadratic graph, quadratic graphs need to look something like this, okay? It doesn't matter if it sits on this line, or it goes beneath this line, or rests above this line, as long as it's a curved graph like this, or even if it's a negative, so this would be if a is positive, so let's write here, if a is positive, then it looks like a happy face, and if a is negative, then it looks like a sad face. Okay, but either way, they're still going to be a curved sort of thing. If I've got something that's just going up, it means that I'm just looking at this section here going up. I need to extend this domain out a little bit so that I can get more values in and look at where the actual turning point is. So to do that, I am just going to extend this out a little bit. Let's extend it out this way, and so let's say this is going to be -2 and -3, and let's see if this gets us anywhere. So if x is equal to -2, y is equal to -2 squared plus 3 times -2 minus 10. This is 4. This is -6, this is -10, this is going to give me -12. Since 4 minus 16 is going to give me minus 12. Then minus 3 is what's going to give me the curve going back up. So this here is the turning point of minus 12, or in between these two would be the turning point. And if I wanted to say minus 3 squared plus 3 times minus 3, then minus 10, this is going to be minus 10, and then minus 4, there's going to be a line of symmetry between these two, is going to be minus 6, and that's going to be your x and your y values. That's what splits these up here. Okay, so hopefully this makes a little bit of sense why I've had to extend these. So what I'm going to do now, I'm going to get rid of all this working out, and we're going to have a go at plotting this kind of graph here. Okay, so let me get rid of all of this, and let's actually add some axes. So in order to draw some axes on, I want to draw a shape, and I'm going to have an axis that do this. So I'm going to look something like this. There we go. Okay, so now that we've got this, we can say we know this is definitely the origin, and we know it has to go down to minus 12. So let's just look at some important points here. So if the bottom of this, let's have down here being minus 12, and it's going to have to go, this is going to be minus 10, minus 8, minus 6, minus 4, minus 2, and then 0. They're a little bit skewed. Your graphs in the exam will be perfectly drawn out for you. And then going across this way, trying to keep to the, actually let's make a different scale. Let's say this is 1, this is 2, this is 3, and this is 4, and this is minus 1, minus 2, minus 3, minus 4, so minus 1, minus 2, minus 3, minus 4, and 1, 2, 3, 4. And then going up, that's going to be 2, 4, 6, 8, 10, and 12 at the top. Okay, so this is our axes that we've used here. Then we would just plot all of the points. So we'll start with a minus 4 and minus 6. We said minus 6 was, this was 2, 4, 6. So this is a point here, minus 4, minus 6. Then minus 3, minus 10 is going to be down here. Then the minus 2, minus 12 gives me here. Minus 1, minus 12 gets me here. 0 goes through minus 10, so that point there. 1 goes through minus 6, which was this point up here. 2 goes through 0, so that point there. And 3 goes through 8 up here, which is that one there. Okay, so you can tell now we have a curve, and then you just want to, with one straight line, try and go through all of the ones possible, and it should be basically symmetrical about this point. Okay, so this is how we would draw quadratic graphs. There's really nothing more than this. As long as we can recognize whether it's going to be positive or negative, we can always sketch a graph, knowing that this plus c is still the y-intercept. So notice how, because this was a, this diagram should go through minus 10 there, instead of having to redraw it. Again, this is very rough, but we can see that because this value on our equation here is minus 10, then our line passes through minus 10. Okay. And we could actually use this drawing of a quadratic graph to actually be able to solve this quadratic equation. If we say that this quadratic here would be written as x squared plus 3x minus 10 is equal to 0, we can solve this by having drawn this graph. And the solution is, we're looking for what are the values of x when y is 0, and that's just when y is 0, where does it cross the x-axis? So we know it crosses at 2, so one of our solutions is x equals 2. And our second solution would be on this side. This is again a very rough sketch, but if we were to go further this way, since we know it's symmetrical about this point, if 1 is minus 6 and 2 is that, if we were to go 1 extra back, this is going to be minus 5 where it passes through. And so our second solution is x is equal to minus 5. And you could verify this. You could do the algebra and then factorize and then solve for both of these things, but you will find that the solutions to this equation are x equals 2 and x equals minus 5. So not only can we draw these quadratic graphs, but they'll actually help us to solve these equations. Now, if we had something slightly different, let's say we said that this was equal to 1, then this is no longer going to be the same solutions, because now y is equal to 1. So we have to look, where is y equal to 1, and that would be about here, and then we draw a line across, and then we'd see where are those intersections, and those would be our values for x. So this grid isn't obviously drawn as accurately as it will be in the exam. In the exam, you'll be able to just look for where they intersect and then see that that will be the x coordinate when y is equal to 1, and those would give you your solutions. So hopefully this helps. Thank you for watching. Hello and welcome to this video. In this video we're going to be looking through how to solve some questions, some practice questions on drawing quadratic graphs. Okay, so this first question, we've actually been given the table, we've been given the equation here as y equals x squared minus 2x, and they were asked us to first of all complete the table for 2 marks. So we're going to do what we've always done through linear, quadratic, whatever it may be. We're just going to substitute in the x value. So if we were to substitute y is equal to minus 2 squared minus 2 times minus 2, well, minus 2 squared is going to be 4. Minus 2 times minus 2 is also minus 2 squared, becomes plus 4. So this is going to be 8 over here. If y is equal to minus 1, they've solved that. Y is equal to 0, they've solved that. If y is equal to 1 squared minus 2 times 1, then 1 squared gives me 1, minus 2 gives me minus 1, so this is going to be minus 1 here. Then if I put 2 in, y is equal to 2 squared minus 2 times 2, and this is going to give me 0, since this is going to be 4 minus 4, which gives me 0, and then you can see there's going to be a line of symmetry here, but let's just make sure. Y is equal to 4 squared minus 2 times 4. This is going to be 16 minus 8, which is going to give me 8. So as soon as you found this line of symmetry where it starts to reflect, you can start filling in some extra gaps here. Okay, then on the grid, draw the graph of y equals x squared minus 2x, which we've got the coordinates for now. From the values of x from minus 2 to 4, which is what we filled out. So then we just have to plot all of these points. So when x is minus 2, y is 8, so that's up here. When x is minus 1, y is 3, so that's actually dead in the center of this one here. There we go. When x is 0, y is 0, so that's going to go through there. When x is 1, y is minus 1, which is actually going to be just underneath the 1 there. Underneath the 1 there. Then when x is 2, y is 0, so that's going to be there. When x is 3, y is 3, so that's going to be across from here all the way over to there. Trying to draw this as accurately as possible. And when y is 4, when x is 4, y is 8. Okay, and now we want to draw this, so we're going to have to join up these dots as accurately as possible. So try and get through every dot and try and make it a smooth curve, and it should look something like that. Maybe you could do a little bit better, but around this is completely fine. Okay. Okay, so now let's have a go at a little bit of a trickier question, where instead of getting you to draw any of these graphs, they just want you to recognize what type of graph these things are. So they've given you a table or a representation of all of these graphs that all have different equations, and they've given you a table that is going to ask you which one of these equations is which one of these graphs. So y equals sine of x. We know a sine of x graph starts at 0, it goes up to 1 and then down back to -1. So y equals sine x is going to be this one here. So we go up to 1, down to -1. So that's going to be c. Y is x cubed. Now this is a cubic graph, which means we're going to end up with something. It's got a y-intercept of 0. So this has no plus x squared, and it has a y-intercept of 0, so it's going to have to pass through 0, and it has this point of inflection that we can see in f, so that's f. This is an exponential graph, so 2 to the power of x means that if I have 2 to the power of 0, it should go through 1, 2 to the power of 1, it should pass through 2, 2 to the power of 2, it goes through 4, and it's going to go up by all of the squared numbers. So you can see that it going across by 1 is going to cause it to go up by a lot, and this is going to be graph A here. And then lastly, we have y equals 4 over x. This is a reciprocal graph, meaning our reciprocals are going to look something like this on h. They've kind of thrown a trick at you here because it could have been b if this was a negative reciprocal graph, since all of the x values would become negative and all of the x values that are already negative would become positive, but this is going to be h here. Okay. And finally, we've been given another quadratic expression, and we want to complete the table for these values that are going to give us the coordinates that we're going to be able to plot on this graph. So if we want to substitute in these values, if y is equal to -1 squared minus 2 times -1 minus 1, this becomes 1, this becomes plus 2, and this becomes -1, so this just becomes 2. If we put 0 into it, the x squared becomes 0, the minus 2x becomes 0, this is just going to be equal to -1, and then we can see we've got a line of symmetry here, so we can just fill these out. That's going to be 2, and that's going to be 7, since it's basically reflected at this point 1. Then we can plot all of these points. So when x is -2, y is equal to 7, so that's this point here. When x is -1, y is equal to 2, so that's this point here. When x is 0, y is -1, so down here. When x is 1, y is -2, so that's down here. Then it goes up again to -1, then 3 goes up again to 2, and then 4 is going to go up again to 7. So this is our drawing, and then we're just going to join up the dots, again being as careful as possible, trying to make sure we get a smooth graph that's going to go through all of these and curve at this bottom point here and go back up to there. So that's our quadratic graph. But the last part of this question is now asking you not only to draw this, but to now solve this equation where we have x squared minus 2x minus 1 is equal to x plus 3. So what we said in the revision video is if we wanted to solve these for this equation is equal to 0, it would be the point where they pass, where the line y equals 0. And so what we're saying here is instead of the line being y equals 0, this has to pass through the line y equals x plus 3. So we can plot this. Since we know the y-intercept is going to be 3 and the gradient is 1, so going across 1 is going to go up 1, across 1 goes up 1, to there, across 1, then goes up another 1, across 1 goes up 1, so it's actually going to pass through there, and across 1 goes down 1 when we go backwards, and then across 1 goes down 1. So this line here, if we draw a straight line through all of these, this is the line x plus 3, or y equals y. Okay, and from there we can solve that for these two equations. So these two equations are equal to each other when x is equal to 4 and when x is equal to -1. And those are your two solutions. This is all the questions we're going to go through. Hopefully these aren't too complicated, and thank you for watching.